In the last video, we looked at direct comparison. In this video, we're going to take a look at what we call limit comparison. And just like direct comparison, this is actually a pretty easy test to look at, to use. You could almost do again this in your head. In the last example, we had, whoops, sorry, get my pen here. In the last video, we looked at the summation as n goes from 4 to infinity of 1 over the square root of n minus 1. And we said that this diverged. You can look at the last video to look at the proof of that one. But what would have happened though had we done, instead of doing minus 1, what would have happened had we done the square root of n plus 1? Well, if we look at our comparison b sub n, which would be the 1 over the square root of n, we know from the last video that this diverges. But when we did our check, our rule says that the original a sub n has to be greater than or equal to my comparison. Well, let's take a look at what happens here. Well, my comparison is this 1 over root n. My original is this 1 over the square root of n plus 1. Well, this I know diverges. However, this is smaller than my comparison. Well, if this one diverges, remember, this one's going to go off to infinity, but this is smaller than it. Well, this one, the original, it could diverge. In other words, it could go off to infinity, or it could converge. If the comparison is going off to infinity, this could stop. The original could stop at any time before that because it is smaller. So as a result here, because this fails, in other words, my check here fails, we would say that direct comparison fails. And if that happens, we use something called limit comparison, and that's up here. Now, limit comparison will always work, even when direct also works. So this is actually one of the better tests to use. The only problem is it requires more work on our part. And as you notice, again, we're going to compare our original and our comparison, b sub n and a sub n, both have to be positive. And what we do is we make a limit. We put the top, the original, over the bottom, and we look at what we get. If we get a constant, finite and positive, then we will say that the series converge or diverge based on our comparison. So in other words, if b sub n converges, a sub n converges. B sub n diverges, a sub n diverges. So let's take a look at an example here. Now, for a problem like this one, I could probably use direct comparison if I only look at what matters the most. This is really what I'm looking at. But it gets really ugly. We'll talk about that if I compare the original with my comparison. So let's take a look at this example. My original is a sub n. That is this n to the 4th plus 10 over 4n to the 5th minus n cubed plus 7. Well, my b sub n, remember, I'm only looking at what matters most. The 10 doesn't matter, the n cubed doesn't matter, and the 7 doesn't matter. What I'm really looking at is this n to the 4th over 4n to the 5th. And heck, if I can even reduce that, this is really 1 over 4n. And if you really a lot of fun, you could don't even worry about the 4, just make it 1 over n. So just like direct comparison, we are going to only look at our comparison one, 1 over 4n. And this is a p series. We can look right here, where p is 1. Therefore, the series here diverges by p series. So I know that my comparison diverges. Now, if I wanted to do, let's say, don't write this down, let's say I wanted to do direct. Let's try direct. See what happens. A sub n, this has to be what? In direct comparison, this one would have to be less than b sub n. Well, let's try that. N to the fourth plus 10 over 4n to the fifth minus n cubed plus 7. Is that less than or equal to 1 over 4n? I don't know. I don't know. It takes too long. I could check it, but honestly, it'll take too long. So in this case right here, I'm not going to do direct comparison. It's too complicated. So I'm going to use what's called limit comparison. And what limit comparison says to do is we just want to see what's happening big picture. So we take our original, n to the fourth plus 10 divided by 4n to the fifth over n cubed plus 7 over b sub n, which is this 1 over 4n. So we have a sub n on top, b sub n on bottom. Now, if I simplify this, this is a limit process, so we have to write down that limit every time. If I simplify it, if I invert and multiply, oh look, I'm going to get 4n to the fifth plus 40n over 4n to the fifth minus n cubed plus 7. And we know with this limit, this is just our horizontal asymptote rule. So I get rid of this, 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 and this, and I'm only looking at, oh look, this function right here, which is 1. This is finite and positive, and I'm going to write that down. And my rule says if I get a number that's finite and positive, we can say that the series now diverges, because my comparison diverges, by limit comparison. And there's our answer right here. So the limit comparison is actually very neat, and it's becoming very big on the AP. So you really want to know how to use this one. You will see this on the AP test. But also, again, it works when direct comparison will also work too. It's really kind of a neat little rule. Direct comparison is easier, though, if you can use it. Let's take a look at another example. All right. Oh, no. 1 over n cubed minus 2. Again, think about why they picked 2, why they didn't start at 1. Okay? Because all the rules say they have to be positive. If I plug a 1 in here for the n, if I plug a 1 in there for now, that won't work. It gives me a negative value. So we're going to use comparison tests because all the other tests here will fail. We'll talk about that in another video here. So my b sub n is just going to be this 1 over n cubed. Oh, I know that. That's p series. And I know that converges, but I have to show it. Right? 1 over n cubed as n goes from 2 to infinity. I know that p here is 3, which is bigger than 1. I should write that down. Therefore, this series converges by p-series test. Now, if I try direct, let's try direct here, okay? If I try direct, because this converges, I want to see that does 1 over n cubed minus 2, is this less than or equal to 1 over n cubed? I want to see if that's going to be true right there. Well, let's think about this. Think of any fraction. The bottom here is smaller than this bottom. So what about the fraction like 1/5 and 1/3? Other way around, sorry. This is 1/3. This would be 1/5. Sorry about that. I messed that up. So if I look at the fraction 1/3 and 1/5, is this a true statement? Of course not. That's not a true statement. So here we can say that direct fails. So in the first one, we just said, hey, I don't even want to test it. Like in this example over here, example number 2, we didn't even want to test it. Of course, I messed up there. That should have been greater than or equal to because it diverged. Sorry about that. But either way, we just didn't want to test it because it's too complicated. So we use limit comparison. Here, we directly know that direct fails, so we can't even use it at all. So we go to limit comparison. And in limit comparison, we just want to see big picture looking at that ratio. Is that ratio approaching a number? So we can take the original 1 over n cubed minus 2 divided by 1 over n cubed. And that becomes the limit as n goes to infinity of n cubed over n cubed minus 2, which is, again, 1. This is finite and positive. So therefore, because my comparison converged, and this is finite and positive, the series itself, the original series, converges by limit comparison. Whoops. Comparison. You know what? Comparison. There we go. We'll abbreviate that. Sorry about that. My spelling's a little off today. Well, why I majored in mathematics. So these are the series tests up to so far. Now, one thing very important, please make sure you're always trying these. These are not very hard to do. The whole goal is by the end to be able to do all of this in your head. And what you're going to find out, you get better at them. And the whole idea here is just to find out if something will converge or diverge. We're not really looking to see if, we're not really looking to see what it converges to, just if it converges. So I hope you guys enjoyed the videos here, and I will be back with you guys later on. Thank you.